In this lecture, we discussed the common emitter configuration. In the previous lecture, we discussed common base, now common emitter. So what is common emitter? Now emitter terminal is a common to the input and output. Now we try to draw the diagram for that. Here I am taking the transistor, NPN transistor I am taking. Emitter, collector and base. So arrow mark indicates the terminal is emitter terminal. Emitter is the common terminal for the both input and output. Now here I am making this emitter terminal ground, and this is the input terminal base, and this is the output terminal collector. Now we need to, this is the emitter, and arrow mark is outside means what type of transistor it is? NPN transistor. Emitter material is N, base is P and collector is N. Now here we have to apply the input bias and input supply and output supply. So already in the transistor biasing I explained that always emitter base junction should be forward biased, and we need to apply the reverse bias to the collector. So emitter should emitter, for that we need to apply forward bias to the emitter, and collector should collect the charge carriers. That's why we have to apply the reverse bias to the collector. Now how to give the supply means, now if you see here the base terminal is P-type material. So by giving the positive plate of the supply, we are making this junction forward bias, and negative plate to the emitter. So that's why it is a forward bias, and the supply is connected to the base through the resistor to limit the current, and to measure the branch current, this loop current, we are connecting one ammeter, and range is IB current is in the order of micro. That's why here we need to connect the micro ammeter. And to measure the junction voltage, one voltmeter is connected. This is the voltmeter. Now here the input current is, this is the emitter. Arrow mark is outside means what? Emitter current is going out. Now if emitter current is out means what? IB current is in and IC current is also inside. Now these are the current direction. This also I have explained in the previous lectures. Now we see the polarities. Now if we see the polarity here, this is positive supply is connected to the ammeter. So here we have to take the plus and minus. And here the supply is a variable supply, and the supply is connected to the base terminal. That's why the name of this supply is VBB. And the voltmeter, now this current is IB current, and this voltage is connected between, the voltmeter is connected between base and emitter. That's why we have to denote it as a VBE. This is a VBB supply, and VBE is a voltage, branch voltage, junction voltage. Now similarly we have to connect, and this resistor name, because it is connected to the B, so naming it as a RB. Similarly we have to connect the circuit at the output side. Now output to the collector we need to give the reverse bias. Now collector material is what? N-type material. To make the reverse bias, N we need to connect to the positive plate of the, N we have to connect to the positive plate of the battery. Now positive plate of the battery. Thereby what? Positive is connected to the N material, so it is a reverse biased, and the name, because the supply is connected to the collector, and the name is VCC, and the supply is connected through the resistor to limit the current. So here this resistor name taking it as a RC, and in this loop need to measure the current. One ammeter is connected, and IC current is in the order of milli, so milli ammeter is connected. And similarly to measure the voltage between collector and emitter, one voltmeter is connected, and name of this voltmeter is parameter is, voltage parameter is VCB. Now this is the VCB. And now if you see the polarities, positive terminal is connected. So here the ammeter first positive, next negative, and voltmeter positive and negative. These are the polarities for the meter. Now this is a circuit diagram for the CE configuration. I hope you understood. So how to make the forward bias and reverse bias in the case of CE configuration. Now we will see the VI characteristics for the CE configuration. To understand the operation at the input side and output side, we are analyzing the VI characteristics, and how to obtain that. The procedure is same. Now whatever I have explained in the CB configuration, procedure is same. By keeping the output voltage constant and vary the input supply, keep the output voltage constant, vary the input supply, and observing the input current and input voltage. And if you plot the graph, and the graph look like this, and if you observe this graph is also looking like a PN junction forward characteristics. So here the base and emitter, base is P and emitter is N, nothing but a PN junction. So PN junction, you are applying the forward bias. So for the small voltage, large current flows, and characteristics are looking like a PN junction forward characteristics. Now here first to obtain this output, we have to keep fixed and vary the supply. Note down these two values, and plotting the graph, it will look like on the x-axis we are taking the voltage, input voltage VBE, and on the y-axis we are taking the input current IB, and by keeping the output voltage constant. And after that, after drawing the graph for the 0 volts, now minimize the input supply, and again take one more value at the output, do the same procedure, then again the graph will look like this. Now here this is the 0 volt, and here it is a 2 volt or 1 volt, more than 0 volt. So if you observe here, output voltage, if you go on increasing, the graph is moving away from the y-axis. Now earlier in the CB, graph is moving towards to the y-axis. Now in this CE configuration, graph is moving away from the y-axis. So this is also because of the early effect. Now what we discussed in the early effect, because the output voltage, so now this is the base, and this is the collector, this is the depletion width. As the output voltage is increased, reverse voltage is increased, depletion width is increasing, thereby the effective width of the base reduces. So here the number of charge carriers are very less, that's why IB current reduces with the increasing the reverse voltage. That's why the graph is moving away from the y-axis. Now this is about the output characteristics. Sorry, this is about the input characteristics. Now we see the output characteristics in the next slide. So this is the output characteristics. So how to determine? Again, the procedure is same like in a CB. So by keeping the input current fixed and vary the output supply, and note down the output current and output voltage, and plot the graph, then the graph look like this. So now in this graph, on the x-axis we are taking the output voltage VCE. Here you can see this is a VCE voltage, and output current is nothing but a IC current. So we are taking IC current on the y-axis, and by keeping the input current constant, what is input current? IB current constant. So and if after observing the values, if we plot, graph look like this. But in the CB configuration, so for all the input values we got the constant output current, but in this case, so linearly it is varying. After some point we are getting the constant current. So this is the CE configuration. Now as a transistor we can operate in 3 regions, that is saturation region, one is saturation region, and another one is the active mode, and another one is the cutoff mode. So total 3 regions are there. If the input current is 0, if we are not applying any input current, then the output current also 0. Here you can see. So output current is also 0. This mode or this region is called the cutoff region or cutoff mode. And if we apply the large current, now here you can see, so this region is called the saturation region, where the current increasing, where the current is maximum, IC current, output current is maximum. So that region is called the saturation region, and in between it is called the active region. So in a cutoff and a saturation region, when we are using the saturation region, so transistor acts like a closed switch. It acts like a closed switch. And in the cutoff region, or cutoff mode, transistor acts like a open switch. In the active region, we can operate this transistor as an amplifier. So already in the first slide, in the introduction, I explained that we can use this transistor as an amplifier and also switch. So when we are operating this transistor in the cutoff region and a saturation region, we can operate this transistor as a switch, and in the active region, we can operate this transistor as an amplifier. And if we see the parameters for the CE configuration, the input impedance. Input impedance is the ratio of change in input voltage to the change in input current. So input voltage, input current we have to take, and similarly reverse voltage gain. Now input voltage, input current. Reverse voltage gain means input voltage to the output voltage by keeping the input current constant. Similarly, we have to calculate the values for the current gain and output admittance. Output admittance is the ratio of output current to the output voltage, and output forward current gain is output current to the input current. It is a ratio of change in output current to the change in input current. So now these are the parameters in the CE configuration.